Okay, so let me turn the record on. I recorded yesterday's also and posted it. If you want to review it, this stuff's pretty complicated, so it might be one that you would want to review.
Okay.
All right. So.
Oh yeah. So this is actually just mostly review, just because I'm still having trouble setting up the problems in a way.
Okay. Go ahead and give me one. Let's do one.
Well, so just to start, can we just do a simple one just so I can refresh?
Yeah. Yeah, for sure. Go ahead.
X minus 2 and all. That's all for the fifth.
That's what?
Sorry, X minus 2y and everything to the fifth.
Okay.
And it wants you. Let's see. It just wants you to expand and simplify.
Okay. So let's write the first term. What goes there?
Isn't it just 1?
In fact, hold on. Let me start it down here because we're going to have 5 terms, so I'm going to need a lot of room.
Let's see.
Okay.
Oh wait, this is using Pascal's triangle, actually.
It's using Pascal's or it's using the binomial expansion theorem?
It's using Pascal's.
It's basically the same thing. In other words, Pascal's triangle are these things right here that I'm about to write. Okay? In other words, I don't know how to separate them. I can solve this using the binomial theorem, and the binomial theorem relates to Pascal's triangle quite nicely in that all of these n choose r's are Pascal's triangle.
Great. Let's see. So I actually read the wrong problem, so that's why I was getting confused.
Okay.
Let's see. It's 1 plus 2x and to the 11th.
Okay. And what do they want? They want every term, or do they want the...
They want the first 3 terms and the last 2 terms.
Okay. So, we need to know the binomial theorem. Okay. I can either write it out, or do you know it?
I have it written down.
You know, it's probably better if you don't look at it. Well, go ahead and look at the way it starts. It's important that you know it, but it's good to see the pattern also that develops, because it's the pattern that's important.
Yeah.
So what goes in our first term right here?
X.
In this case, so it's 11 choose 0. Okay? In other words, R always starts out at 0 on the first term.
Okay.
And then you have the first term to the 11th power. That's A sub n. That's n. Okay, so just reading directly off of the binomial theorem, that's the first term. We'll simplify it later. Let's see if we can find the pattern here. The second term, what goes here?
11 choose 1.
Uh-huh. In other words, R is going to count from 0 up to 10, basically. And what else goes here?
It's 1 to the 10th.
To n minus 1, yeah. In other words, this is n minus 1 and n is 11, so it's to the 10th. And then we pick up the second term, the b term. In this case, 2 to the x, to what power?
The first power?
Yes. In other words, the second term of the series always is the second term to the first power. So here's the first term of our series. Here's the second term of our series. Let's follow the pattern. That's why she wanted you to do the first three. What goes here?
That would be 11, choose 2.
Okay, what goes here?
Times 1 to the 9th.
And what goes here?
2x squared.
Right. Okay. So there's the first three terms, and we can see the pattern developing. So what's the last term? Let's work backwards.
The last term would be 11, choose 11? 10?
No, you're right. 11 choose 11. Excuse me. There are going to be 12 terms. There's always one more term than this n is. So since there's 12 terms, the last term, r, needs to be 11 because it's counting from 0. So the 12th term is going to be 11 choose 11.
Okay.
And what else?
Oh, no, it would just be times 2x to the 11?
Yeah, and make sure you always put parentheses around there because that's real important. If I don't put parentheses around there, it changes it.
Yeah.
Okay? Now the second to last term.
11, choose 10.
We have an A term here.
So it would be times 1 just to the first.
Exactly.
Times 2x to the 10th.
You got it. And notice by having you do the first three terms and the last two terms, you really get the pattern down.
Yeah.
In other words, there's no doubt in my mind right now that you could do the fourth through how many we wrote? 5 of them, and there's 12 of them, so you could do the fourth through the 10th.
Okay.
Okay, so that's a simple one. What else you got? We were about to do one last night when we ran out of time, where you had to find the coefficient of the x to the sum term, and it was a complicated one. It was a hard one. You want to do that one, or have you already done that one?
I don't remember which one it was.
Yeah, it was something like x plus 1 over x, or maybe x squared plus 1 over x, all to the 6th or something. And they wanted to know the coefficient of the x cubed term. Definitely harder than your average binomial expansion kind of problem. It's the only reason I thought you might want to do it again. I don't know. We just talked a little bit about it last night. Right towards the end of our session, we started working on it. I was trying to explain to you how to find it, but I don't know if you finished the problem or not.
Well, I don't know if this is the one, but I have to find the 9th term of 2x squared minus 1 over x all to the 21st.
That sounds right. What is it again?
Let's see. 2x, find the 9th term of 2x squared. Minus 1 over x in all to the 21st.
Okay. Now, when they say the 9th term, is that what you mean, or is it the term where x has an exponent to the 9th?
They mean the 9th term.
The 9th actual term. Okay. Cool. So, let's do the first term.
All right. It would be 21 to 0 times times 2x To the first?
To the 20, to the 21st. Right? In other words, if you look at your binomial theorem, that first term is n, choose 0, times a to the nth. So it's 2x squared to the 21st. But critical is the parentheses. You can't, it means something different if you don't put the parentheses. Okay? And there's no b term. The first term never has a b term. Let's write the second term just so we know what everything's going to look like. It'll include both variables.
So 21 choose 1 times 2x squared to the 20th times negative 1 over x to the first.
Okay. That is the second term. So what is the ninth term going to look like? That's the first term. That's the second term. This is the ninth term.
21 choose 8.
Good.
Times 2x squared to the 13th.
Yeah, they have to add to 22. In other words, the ninth term, notice the first term, 1 plus 21 adds to 22. The second term, 2 plus 20 adds to 22. So the ninth term, this number and the number of the term have to add to 22. So it's got to be 13. And what about the minus 1 over x?
That would be to the 8th.
Yeah. In other words, this is always 1 less than the term. It was 1 on the second term, so it's got to be 8 on the ninth term. And that's pretty much done.
Can you simplify that at all?
Yeah, you can. Let's work with the number first. What is 21 choose 8 equal to? Let's state it in factorial definition.
It would be
in other words,
21
factorial in the numerator. What goes in the denominator?
8, but I don't know how you can cancel
8's one of them, and also 21 minus 8 factorial is one of them. Okay?
Is that just like a rule that...
No, yeah, the rule is this. The rule is n factorial over, the book shows r factorial n minus r factorial. And remember, I said the way to memorize this is there's 2 n's and 2 r's in it. As long as you remember that there's 2 n's and 2 r's and you always start on the top with n factorial, you can't really go wrong. Okay? So that translated to 21 factorial over 8 factorial times 13 factorial.
Wait, and then is r just the term number? Is that why it's 8?
No, r is 1 less than the term number. We're looking for the ninth term, so r is 8. Remember, our first term, r was 0. Our second term, r was 1. So our ninth term, r is going to be 8.
Okay.
And the 22nd term, r is going to be 21. In other words, the very last term is always going to be 21, chosen 21, like that, for starters. That's always the last term, is n, choose n. In other words, r has been counting up approaching n through every term. Finally, on the last term, it gets to n. But that's neither here nor there. We need to figure this out, so we need to simplify that. Well, that you need a calculator probably to do. Do you have your calculator?
No, I can go grab it.
Probably ought to get it and figure out how to do factorials on it. In fact, your calculator has an n choose r, doesn't it?
Yeah.
That's probably the easiest way to do this problem. Just go ahead and put in 21 choose 8. Because I'm going to need a calculator regardless. I can do some cancellation here, but I'm still going to have 21 multiplied by 20 down to 14, and all of that divided by 8 factorial. So that's not an easy one to do manually.
Yeah. The calculator says 203,490.
Okay, 203,490. Okay, that's that part. Now let's simplify this part. How can I write that?
That would be 2.
For the moment, let's just write it as an exponential. 2 to the 13th times x to the what? Can't hear you. There's too much background noise.
Let's see, 2x, 2 to the 13th times x to the 26th?
Yeah. 2 times 2 to the 13th, x to the 26th. Now this part here.
And that would just be negative 1, let's see. That would be negative 1 over x to the 8th.
Well, that's what's written there. What does it simplify to? What's negative 1 to the 8th? In other words, that's the same thing as negative 1 to the 8th over x to the 8th. But what's negative 1 to the 8th?
Negative 1.
No. When you take a negative number to an even exponent, it always turns positive. Just like negative 1 squared would be, in other words, that's really that. I'm sorry, I didn't put the parentheses around it, and it's needed. Without the parentheses, you were right. The answer would be negative 1. But you need the parentheses. In other words, it started out in parentheses. I just forgot to add them when I separated it into a numerator and a denominator.
Yeah.
So this turns in to positive 1 over x to the 8th.
Okay.
Which is the same as writing x to the 8th right there. So now there's further simplification we can do. What's the new x exponent?
X to the 18th?
Yeah. And there's probably that's the answer they're going to give you. They may actually say 21 factorial over 8 factorial times 13 factorial times 2 to the 13th times x to the 18th. And given the way they gave that one answer as 10 choose 5 times 2 to the 5th times 3 to the 5th. Remember that one?
Yeah.
So actually they might even give the answer like this. 21 choose 8 times 2 to the 13th times x to the 18th. I bet they do. I bet that's the way they give the answer. That would fit that other problem we did.
Okay.
All right. What else you got?
Let's see. So one of those that are like the find the coefficient of a certain exponent.
Okay. What's the...
Or what is it? Here, it's actually a different one. It's just, it wants you to find the constant term in the expansion of x plus 2 over x squared. Or just the 2x, or just the 2 is over x squared.
X plus 2 over x squared?
Yeah, and then all of that to the 15th. And it wants you to find the constant term in the expansion.
Of which term?
It doesn't say, it just says find the constant term.
Oh, okay. I see what's going to happen here, I think. Let me think for a second. Yeah. The constant term is going to be when the exponent on this matches the exponent on that. Because we're going to have an a to some n times a b to some n minus r.
Oh, okay.
And the constant, in other words, there will be a constant term as we work through this series. At some point, the exponent on this is going to match the exponent on that.
Yeah.
And then that will produce a constant, because then the x's will cancel, and you'll end up with a constant. So let's figure out where we have to go to get that. In other words, the second term is what? We don't really even need this part, but it's helpful to write this in as a counter.
Okay. So let's start with the second term. It would be 15 choose 1.
Okay.
Times x to the 15. Oh, it would be x to the 14 times 2 over x squared to the first.
Okay. Notice that produces an x to the 12th. Right?
Yeah.
Okay. So we want to go and find the term where that produces a constant. And x is going to count down here and count up here. Okay? So, let's see. If we go plus, 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 what do we need that to be? This is going to count down by 1. This is going to count up by 1. So, let's see. If we go down 6 terms, we'll have an x to the 8th. And we will have a 2 over x squared to the 7th. Well, that's too much. Now we have x to the 8th over x to the 14th. So let's go to 10. In other words, there's a little bit of trial and error here. If the x has a 10 as the coefficient, then the second term has to have a what?
Let's see, have a
What would be perfect? A 5, right?
Yeah.
Because now the x to the 10th is going to cancel out with this x to the 10th. So that's correct. Which term is this?
The The fifth term? Or
4 greater than 2. So it would have to be the 6th term. Right? Look at the second term goes with the 1. And this is going to keep going up, so the 6th term has to go with a 5.
Okay.
Okay, so now they want the constant term, right? They want to know what it is, right?
Yes.
Okay, so
Yeah.
what goes here? 15 what?
15 choose 6.
No, you were right. I thought you had it. Choose 5. This thing counts up also. And the 1, in other words, this increases by 1 each term. And this 1 went with the second term, so a 5 has to go with the 6th term.
Okay.
Okay? So this is our constant. Now we just have to figure out what it is. Well, let me erase everything else. Is that okay? At least I'll erase all this part, because we figured out which term it had to be. So the constant itself is going to be what? Let's give the answer.
15 choose 5 times 2. Or times 2 to the 5th.
That's the constant, exactly. Because notice the x will be x to the 10th in the denominator, and it'll cancel out with that, leaving you with a constant. And that's the only term that will not have a variable in it. So I was a little thrown at first, because both of these have variables. You would think every term would have a variable, but there is one term exactly where those exponents are going to cancel each other.
Yeah.
All right. What else?
Let's see. This might have been the one from last night. They want you to find the coefficient of x to the 5th and the expansion of x plus 2 times x squared plus 1.
The expansion of x plus 2 times what?
X squared plus 1.
They want.
And then x squared plus 1 to the 8th. All to the 8th.
So this is a double binomial expansion?
Yeah.
Okay. Now, what do they want to know?
The coefficient of
The x
to the 5th.
Okay. Notice that if I expand just this, and multiply it by this, then I want the coefficient, or the exponent of the x to be 4, right?
Wait.
In other words, I'm going to expand these separately. I'm going to expand this one until I get a coefficient of x to the 4th, and then I'll know that when I multiply it by that, it'll be x to the 5th. I'm assuming that's what this problem is.
All right.
This is a bit of an odd one, but not really. I mean, I think I understand it. That's what they mean. So I'm looking for the expansion of this and that coefficient right there. Okay, so let's figure that out. So how do I get x to the 4th? Well, what's the first term?
The first term would be 8 to 0 times x squared to the 8th.
Correct.
And that's it.
Okay. Yeah, there is no second term yet. Okay, so what am I looking for? I'm looking for x squared squared. That will give me my x to the fourth. So I've got to go down to the term that has x squared squared. Now remember, this was the first term. So which term do I need to go to?
You need to go to the fifth term.
Notice that the second term is x squared to the seventh.
So the fourth term?
Notice that the first and the eighth add to 9, second and 7 add to 9. This has got to be the seventh term. You see why? When we're counting from 8 to 2, that means we got to go up by 6. We got to go from 1 to 7.
Okay.
Okay? But the better way to do it is really to figure out these patterns. That 1 plus 8 equals 9. So that's the first term, the number of the term and the exponent of the first part always equals 9. Second term is a 7, the seventh term is a 2.
Yeah.
In the ninth term, it's a 0. Okay? But this is the critical part right here. Is where is the exponent of the x squared term equal to 2? It's the seventh term. What goes in here?
You choose.
What is it?
8 to 6.
Yeah, the sound is bad there. I kept getting background noise every time you said the number. Okay, so they want the coefficient of the x squared term, right? In other words, by the time we get to the seventh term, the 1 comes into play. So that's involved here also, but it doesn't matter what power that is. It doesn't change anything. So I can ignore the 1. So the only number I have to actually figure out is 8 choose 6, which is 8 times 7. That's 56. Okay? So this seventh term would have 56 as a coefficient. And when you multiply it by that binomial, it doesn't...
Really fast? So you would write 8 choose 6 like as a factorial? You would write that 8 factorial over 6 factorial times 2 factorial?
No. That is the... Remember, the way this works is you cancel out 6 down. So this is 8 times 7 times 6, but everything from the 6 down cancels out by the bottom. Hold on a second. I made a mistake. Sorry. Yeah, 8 choose 6 is 8 factorial divided by 6 factorial times 2 factorial. So it wouldn't be 56, it would be 28. In other words, this cancels out everything but the 8 times 7. So you end up with 8 times 7 divided by 2.
Okay.
Okay? So I can replace that with the number 28. So there is the seventh term of this binomial expansion. Well, that has an exponent of x to the fourth. If we multiply that seventh term by this binomial, we'll have our x to the fifth.
Yeah.
So 28 should be the answer.
Okay.
Because this will also, you also got to multiply the 2 times x to the fourth, but that won't affect the coefficient of the x to the fifth term. In other words, the x to the fifth term is going to have the same coefficient as this x to the fourth term has, and that's 28.
Alright,
What else? We got about 15 minutes.
let's see.
You got probability coming up next?
Let's see. Unit, circle, and radian measures.
Oh, okay. You're going straight into trig. Have you had trig yet?
I think I've got a tiny bit, but not too much.
But this might be the too much, right? In other words, trig goes with pre-calc. So if you're starting the unit circle next, you're headed into trig. That's good. I know trig really well. Probability not as good at. That's why I asked. And statistic not as good at. So there's going to be some subjects you hit, maybe, where I'm going to want you to send me the problems in advance.
Yeah.
Trig isn't necessary. But some of these I might have you do that. It depends on the subject matter. So it would help if I knew what the subject matter was going to be. But all right. So you have another binomial?
Maybe there's one with the factorials.
Okay. Read the problem.
Alright. Oh, right, it just, I think we did something like this last night, and it's just explaining the results using Pascal's triangle. I'm still confused on that.
Okay.
So, like, here, let's see, one of the problems
Notice that when we were using the binomial theorem, it's n over 0, and n over 1, and n over 2. That's the first row of Pascal's triangle. That's the second row. That's the third row. I believe. In other words, let's go back and write Pascal's triangle. Let's just write 4 terms. This was a plus b to the 0th. Notice the zeros matching up. If you take a plus b to the 0th power, it's equal to 1. If you take a plus b to the 1 power, matches up with that, you get a plus b. The coefficients are 1 and 1. If you take a plus b squared, notice a plus b squared is a squared plus 2ab plus b squared. The coefficients are 1, 2, 1. Is it making more sense now?
yeah, I think so.
Okay, same thing is a plus b cubed is going to have coefficients of 1, 3, 3, and 1 on the 4 terms that come out. In other words, it's going to be a cubed plus 3a squared b plus 3ab squared plus b cubed. Notice these coefficients are 1, 3, 3, 1. And when you look at the binomial theorem, the n choose r are these coefficients. So the third term is going to be n choose 3 for the first coefficient. It's going to be n choose 2 for the second coefficient, n choose 3 for that one, or excuse me, n choose 0 for this one, n choose 1, n choose 2, n choose 3, and n would be 3. But so the binomial theorem, the choose part of it, matches Pascal's triangle.
Yeah, okay.
In other words, this number, here, let me explain it a little bit better. This number is 3 choose 0, right?
Uh-huh.
The 3 is 3 choose 1. This 3 is 3 choose 2. And notice that 3 choose 1 is the same number as 3 choose 2. And finally, this last one is 3 choose 3.
Okay.
In other words, you go direct from the binomial theorem to Pascal's triangle. All of those chooses, that was the coefficient of the first term, coefficient of the second term, coefficient of the third term, coefficient of the fourth term.
Okay.
I'm not quite sure how else to compare these, but that's pretty strong. In other words, Pascal's triangle is fixed. We could go on and on with it, you know, rows 4, 5, 6, 7, 8, and the numbers are, I could figure them out by looking at the binomial expansion. In other words, if I said to you, what is this was the fourth row of Pascal's triangle, right? So what would the 10th row look like? What would the coefficients be? What would the row itself look like? That would be a plus b to the 9th. So what's the first number going to be?
Would be 1.
It would be 9 choose what?
Oh, 9 choose 0.
Which is 1. You know it's 1 because the outside of the triangle is always 1. But in terms of a choose, it's 9 choose 0, the very first one of the binomial expansion. What's the second one of the binomial expansion?
9 choose 1.
That would be the second term in that 10th row. The third term would be that, and so forth and so on. And the 10th term is 1 again. Notice that 9 choose 0 is 1, and 9 choose 9 is also 1. So that's how you get the two outside numbers on the fourth or on the 10th row. And the second to last coefficient is 9 choose 8, and all the ones in between. So there are your 10 numbers in the 10th row of Pascal's triangle. The same as the first 10 coefficients of the expansion of a plus b to the 9th.
Okay.
All right. In fact, that would be a pretty good question. What's the 10th row of Pascal's triangle?
Yeah.
Or a better question would be, what's the 27th row or something? And then you would write it out like this. And in fact, the 27th row starts out how?
Um, 27 choose
No,
0.
no. The 10th row started out 9 choose 0.
Oh, 26 choose 0.
There you go. And the last term, the second would be 26, choose 1, and so forth. There would be 28 terms. Notice the third row, excuse me, let's see, that's 2, 3, 4. The fourth row has 4 terms in it. So the 27th row has 27 terms in it. Hold on a second, I might be wrong here. Yeah, I am. The 10th row is actually, let's see, the first row was an exponent of 0. The fourth row was an exponent of 3, so the 10th row, yeah, has an exponent of 9. The 27th row is an exponent of 26. So it is 26, choose 0, 26, choose 1, all the way up to 26, choose 26. There are 27 numbers in that 27th row, just like the fourth row had 4 numbers. And the third row had 3. Okay. What else? Anything?
Oh, sorry, I was on mute. So in the and so if you go in the 27th row, it's like the 26th term, or 26 choose 0, rather than 27 choose 0.
Right. Notice the fourth row was 3 choose 0, and 3 choose 1, and 3 choose 2, and 3 choose 3. This is probably confusing because I've written that on top of the third row, and it applies to the fourth row. I had to write it somewhere. I didn't have room.
Okay. Yeah.
So this is always one number less than the row you are on in Pascal's triangle. So that's why the 27th row starts out 26 choose 0. The same way that, in other words, if you were doing the binomial expansion, now you use the exponent as n. But notice the binomial expansion always has one more term in it than the exponent. In other words, a plus b to the 26th is going to have 27 terms in it, matching the 27th row of Pascal's triangle.
Okay.
Got 5 minutes. Is there anything else you want to go over that takes about that amount of time?
Well, I think that's basically everything.
Yeah, we've covered it pretty good. We even covered multiplying 2 binomials together like that, which is
Wait,
say
that again? I was freaking in and out.
Well, we had to apply it to 2 binomials multiplied together, like x plus 2 times the x squared plus 1 to the 8th. That's different. You know, in other words, we have to expand this and then know that when you multiply it by x plus 2, the x to the 4th term is going to go to x to the 5th. So that's a little different. But other than that, we've covered quite a bit regarding the binomial expansion.
Yeah. Well, yeah, I think that's basically everything I needed help on.
Okay.
Because the idea of each table problem.
Mm-hmm. So how much trig have you had? Just minimal amount?
We haven't started it, but we're wrapping up the binomial expansion unit.
But in previous years, you've had a little bit of trig, right? I mean,
I had a tiny bit of unit circle last year.
okay.
And that's about.
Okay.
But yeah, I didn't really understand.
They like to teach trig slightly different than, well, not really different than me. I don't like their forcing people to memorize this divided up into 16 slices.
Yeah.
That's what they want you to do. And there are 6 trig functions at each point. So this thing divides up into 16 slices, and there are 6 trig functions at each one. So they're saying memorize 96 points. That's silly. That's silly to even attempt to memorize 96 things. But you can memorize groups of things. You can memorize this group of 3 things, and this group of 4 things, and this group of 3 things. And by putting them all together, you can figure out each of these for all 6 trig functions. I can do it without memorizing that unit circle. So there's a little bit of, I don't want to say difference. It's kind of like factoring. I've never factored using their diamonds or squares or California method. I don't like that method. I factor using my own method, but it works better. That's why I do it. It's simpler, easier to understand, and I try to teach all of my students that are having difficulty with factoring how to factor based on the way I factor, not this diamond method that they like to use. Well, it's a little similar to trig. I don't like asking people to memorize the unit circle, all 16 points on the unit circle. I don't think that makes much sense. It makes more sense to know quadrant 1, 2, 3, and 4, and that all students take calculus, tells you what the plus or minus sign is going to be in each of those 4 quadrants, and that in the second quadrant it's 180 degrees minus angle, in the third quadrant it's the angle minus 180 degrees, and in the fourth it's 360 minus the angle. So basically my method takes every angle and converts it to a first quadrant angle, figures out what the ratio is of the trig function, and then attaches a plus or minus sign based on which quadrant it was in to start with. So for me to answer that unit circle, it's, okay, I got to memorize these 4 things. All students take calculus, that's 4 things. I got to memorize these 3 things. And then I got to memorize the 2 special triangles, the 45-45 and the 30-60. And the dimensions of each, that's another couple of 3-4 things each. Between all of those 4 things, you can solve any angle that's a multiple of 30, 45, or 60 without a calculator. In other words, I can do tangent of 225 real easy by converting it to a first quadrant angle, figuring out what that is, knowing it's in the third quadrant, so it's got a plus sign on it, stuff like that.
Yeah.
That's a preview of what's coming for you.
Okay.
Okay? All right, Sarah. I will talk to you next time.
All right, thank you.
Bye-bye.